Hello. Hey, think you're I think you're muted.
Can you hear me?
Yeah, I can hear you now.
Okay, cool.
How's everything?
Good. Sorry to reschedule, but I had to come to Albuquerque to see some family, so I just
It's
got here.
fine. Yeah. How was the drive? I don't know, is that in New Mexico? I was like wondering where that was.
Yeah, it is in New Mexico. Yeah, it's like 4 hours from El Paso.
Oh wow, that's not that bad. It's like going to LA to like San Francisco.
Yeah.
Okay. Oh yeah, I
Okay.
sent you I sent you something. It's gonna be like kind of like a PDF that I'll be doing like every week. Hopefully I get time to actually prepare it. But
Okay.
I usually do this so that it's kind of like more problems. It's problems from the book that you guys are using, but then I
Okay.
added a few things to it.
Okay, cool. One second. Let me get my pencil.
Cool.
1 second. Sorry.
Oh, you take your time.
Where's my pencil? You need one? I just had it, but. Purple pencil. You didn't see it? I guess I'll just use a pen. That's weird. Okay. I'm back.
Yeah. All right. So what I did was I kind of just started. I don't know if you went to like did you join the frog tutoring?
No, I didn't.
Yeah, because I think I don't know if they usually record it. Do you like maybe you should join it and then we'll just I'm already in Zoom right now, so
Right. Okay,
I don't know what
so
they
you
do.
didn't do anything on the frog?
Not yet. Like I'm not gonna do anything on the frog. I'm just gonna let it be, and then we'll just go on Zoom.
Oh, okay, cool. So I have it set for an hour and a half on the frog.
Yeah, that's fine. Like I guess what we can do is like just similarly like every time we can just set the time, and then it can be like 1.5 or like 2, whatever.
Hmm.
And then like because I'm looking at this now like I've only done this like a few times, but I mean it's not like I'm not familiar with it, but Zoom is the one I've been doing for like 5 years. So like
Right. Yeah, and I
uh,
just feel like Zoom is a lot more user friendly and it's
exactly,
easier to
yeah.
share stuff. So
Yeah, but I know you can still share screen with Frog. Have you done that before? I don't know if you can.
I know that there's a way to do it, but it was just so difficult to do it. I don't know. Like every time I tried it with the tutor, it just like wasn't
There's
really.
always some kinks. That's fine. Okay, so yeah, we'll just do Zoom. But can you see my screen?
Yes.
Okay.
Mhm.
So like I guess how we're gonna. I don't know if you had a chance to look at this, but
I was
th- th-
checking the email. I saw this when I was gonna join the meeting. I was like, oh, he sent like a whole itinerary, but I didn't look
yeah,
at
it's kind
it.
of like almost as much as your lecture notes, right?
Yeah, right. But
Yeah.
that's cool. It has like the videos and things like that. It's really
Yeah.
organized. So thank you.
Yeah, so that's why I was like saying like this is probably the most it's gonna be.
Yeah.
Like as you progress, because like you guys have an exam every week. That's like crazy. You guys have an exam every week.
No, it's not every week. It's every like 3 or 4 weeks.
Okay,
Yeah.
okay, that's still a lot
So,
though. But yeah, like what I'm gonna try to do is like with each chapter, because what I did here, just to like since this is the first time, what I'm gonna do is I'm gonna have some theory, and that's why I was asking you like, oh, which ones do you want to focus? Because there's so many, right? There's so many we can like
right.
talk about,
Yeah.
and
I
then like
think if
that.
we go over the homeworks
Okay.
and this example problem. Did I send you the example problem?
Yeah, like three of them. Unless there's like more. There's like
It
three
was
I
like
can't remember.
example hold on. It was example 14.6 something.
Is it the one with the Y? Kind of like the Young's modulus?
Stretching a wire. It was about stretching a wire.
Yeah, I think that's the first one, yeah.
Yeah. And then I'm sure the Venturi meter, like Venturi tubes, are going to be on the exam too. I was actually watching YouTube videos on Venturi meters last night. So I'm really familiar with it. But I actually have a question on that, on that subject. So, have you heard of the chemistry tutor guy on YouTube?
There's a lot of them. I do, in fact, I do like keep track with like a lot of them. Like I have a library of like YouTube videos.
Okay.
Which one though? Which one? Who's the guy?
It's like his name is that chemistry tutor guy.
Oh, that's the name. Okay.
Yeah, and so he was going over the Venturi tube, but I was confused on like how he. Watch here. I'll show you. I'm gonna share my screen. Okay.
Okay, go ahead. Let me stop this first. Go ahead.
All right, 1 second.
Oh, I saw this one. Yeah, but I wasn't gonna add this to like because it seemed like there's a lot to it and it's kind of boring. But anyways, yeah, what about it?
But I was understanding it up until, well, I mean, I guess I still understand it. It was just like more of a curiosity question more than anything.
Okay, go ahead.
So let me make this bigger. Okay. So pretty much this problem. Hold on, I'm gonna minimize this. Okay. So this problem gives a point A and a point B, right?
Yeah.
And it has 2 water levels, and the distance between the 2 water levels is 61.2 centimeters.
Yeah.
And then so we're using Bernoulli's equation.
Yep.
Is the reason why we're using it? See, like I don't know, when I'm looking at a problem, I don't know if I'm going to use Bernoulli's equation or just use the continuity equation. I don't know.
I see what you're saying. So this is like the whole concept of Venturi tubes or Venturi effect. Like, we'll probably go over it, but like since we're talking about it now, what it is this equation right here at the bottom. This is in fact the Bernoulli's equation. This is the general one, and I think this is the this is the energy one because there's also the head version. Okay. So what you do here is like you're talking about the height, like which one do you use? Either the AV1 equals A2 times V2. You technically use both. Like it just depends on, like these are just equations. It just and that's like kind of like a hint with these problems. I did have the same issue before where how do you like start this? And a lot of like starting.
I think that's my biggest issue. Yeah, that's my biggest issue. Like I don't know where to start.
Because it's very like, in fact, like an equation will in fact give you an output, but garbage in, garbage out. It's the assumptions of like what you put. Like for example, this one, you need to know before you start using the whole Bernoulli equation. You need to know what you can cancel, and that's really what it is. The assumptions you make in the beginning will lead you to like the right or wrong answer. So like, if you're gonna be using the continuity, you gotta look like, for the most part, what's given for the continuity are like the sizes, the diameters. Like you'll definitely get like an A1 or A2. Like that's typically given, unless you have to like work at, like, and then you have to find either V1, and you'll be given V2, but then the other one you don't have. And then what for a Venturi tube, like one of the questions that you requested is you actually the expression for that is you have to use the continuity equation and solve it for either V1 or V2 and then plug it inside the Bernoulli.
And and that's exactly what he did here. And so that was my next point that I was going to get to. So he pretty much wrote out like what was given. So this is area 1, area 2, this, and there's the height. And he said since point A and point B are at the same height, and we can cross out rho GH on both.
So this is where like the most confusion. Everyone gets confused like which height, because like you have this. Have you guys talked about manometers before? Like manometers, whatever.
I don't think so.
Okay, so like for a Venturi tube, I kind of like. I mean, it's just a system. Like if you look at this dumbbell-looking thing, this is like the Venturi tube, like from A to B. And then where you have these the water level heights, like up top, is we technically call that like a manometer or manometer. And then like, you know how like the equation, this delta P at the bottom, the P1 minus P2?
Yes.
So this P1 minus P2, every time you see this difference in like pressure, we call it as like Pascal's law, whatever.
Right.
But this is where the top part, the manometer, the difference in heights, this is where you apply that, where the difference in heights of the water column. That's the only time you apply that.
So these difference in heights of the water correspond to pressure.
Yes. Yeah. So that's the time that's where you apply it. Like how you combine these is because that's the height. That height right at 61.2. Because you're gonna have a height that P1 minus P2. You're gonna have a different height from H1 and H2, right? This H1 and H2 is not the same height for the column of water.
Right. Exactly.
This H1 and H2 really is A and B. That's why I don't like how they're labeling it. It's like it's actually A and B. Like that's why they cancel out because they're in the same level.
Right. That makes sense. Okay. So my real question, like the main question I had was, okay, so I understand all this that he wrote. He just rearranged. So he crossed these out.
Yeah.
Crossed out the heights because they're the same. Rewrote the equation to get all to the delta P on one side and then the rest of the equation on the other side. But he said to get V2, he pretty much substituted this part. Do you see my mouse?
Okay. Yeah, I see your mouse. Yeah.
Okay, cool. He substituted this for V2.
Yep.
Now, what I don't get is how did he go from A1 V1 equals A2 V2 to this? Because if he's going to divide out A2 on this side to cancel, why isn't A2 divided by both A1 and V1? He just divided it by A1.
He just divided by A2 or A1?
He only divided A1 by A2, but he didn't divide V1 by A2, which I don't get, because if you're going to divide out something, don't you have to divide it out on the whole thing on the other side?
Yeah, I think I know what you're saying. I think what he is doing, he did that already. Like you only have to do it for one. It's multiplied, right?
Mm-hmm.
Like he divided the A2 on the left hand side, so like it's being
cancel
multiplied.
Out the A2. Yes.
Yeah.
But shouldn't it be A1 times V1 all over A2?
Yeah.
Only.
Yeah. You're exactly right. Like it's just.
Is it the same thing or?
It's exactly the same thing. Like it's just
okay.
He just I think what sometimes what people do, like what this guy is doing, is like he doesn't like to group things. So like he wants to group only his A's together. So it's kind of like a ratio, and then instead of like A1 V1, yeah.
Okay, that was just throwing me off because I was like, wait, I didn't know you could do that. But then again, my algebra is not that good because I don't really use it fine. Anymore. So.
Hey, you passed calculus already, right?
Yeah, I did.
No, but like everyone always just like sometimes that's why there's a calculator.
Yeah, I just forget the rules, like the small rules sometimes because
I'm
learning a bunch of new stuff.
Yeah, I know what you mean. Okay.
So yeah, I got that. Okay, cool. No. I guess. Can I just finish watching it really quick to see what he does? To see if I have any.
Yeah, go ahead. Let's look at it. This is actually, I mean, it's pretty interesting. Yeah.
Can you hear him?
I actually, no, I can't hear it. Is it on mute?
No, I have it playing. Let me see. Hold on.
Okay.
Still can't hear it?
Still can't hear it.
Oh, man.
I can probably tell what he's doing, though. I mean, I'm just
but you can just follow along. Okay, cool.
Go ahead. Yeah, just shoot your question, because like a lot of, I guess I'll just talk too, but because I can't hear anything.
Yeah.
But like a lot of these Venturi Tube ones, I mean, I'm guessing most of your professors like review questions are going to be on this in terms of Bernoulli. And it's just,
for sure Bernoulli and the continuity are going to be on it for sure. For sure.
Is your professor a Shiri or whatever? Like your
it's
professor?
a she. She's a woman.
So did she give you guys like, preview problems or a set of them or maybe a practice midterm?
Yeah, she did send problems this morning, but I haven't had a chance to look at them.
Okay.
But we can look at them after I look at this problem because I was already like in the zone for this one. And then so once I finish this, then we can go together.
And then do you have the solutions for those or?
I don't know. I think. Well, okay. You know what? Just forget this. I'll just do this on my own time. Let me check.
Yeah, this one. I think you got this one already.
Yeah. Let me see what she said. Ooh. Okay, she put solutions to homework 2.
Okay, so I think that's the one. The 2 problems, right? It was from homework 2.
Yes. Were you able to look at those?
Yeah.
Practice problems are uploaded to Blackboard. Okay.
I got 2 of them. Like, are the other ones like what's the other like concepts? I guess we can talk about those if you're like shady or like not blurry on those ones.
Yeah, let's do homework 2 because I had no idea what I was doing with that one. And then after homework 2, we'll look at the practice problems. Yeah?
Okay, let's do that, yeah.
Okay. Since you already saw homework 2, like we can just like clear that out.
You guys are using Blackboard? That's our essay. So like, yeah, we usually use Canvas aside.
Yeah. No, yeah, we use Blackboard.
Okay. I think we used Blackboard before, but I think it's just transitioning. Okay, let's look at this.
So here are the solutions. It sucks because she doesn't like she doesn't have the problem there. She just like puts the answer. So I can't see what the original problem said.
Okay.
Hold on. Let me go back. There we go. Okay.
All right. Okay. So like, yeah, like, do you want to go over the first one like thoroughly?
Yes, please.
Okay. Let me share my screen for that one.
Okay. Let me just write down the problem really quick. Hold on.
Okay.
Homework 2.
Are these graded for you guys?
Yeah, but I didn't turn it in because I didn't know how to do it.
If she gives you the solutions, I'm guessing it's just like the midterms are going to be worth more usually.
True, yeah. Well, she has like a due date. Hold on.
I did take a look at I think the second one is on Chegg. The first one I don't think is on Chegg.
Right, yeah. I saw that the first one was on Chegg. All I turned in was the second one because it was on Chegg.
Okay, perfect, yeah. That one is a little, it says tall, okay. I was a little confused with that because there was no picture. Oh yeah, that's also another hint. I mean, I guess you probably know that already, but with the Bernoulli ones, make sure you know how to picture it. If there's no picture, draw it out.
Okay. See, I'm bad at doing that too, because the wording sometimes just throws me off, and I don't know what they're talking about.
I know exactly. Like I said, it's the assumptions. It's more practice. The more,
yeah.
That's what I'm saying. If you're rigid with something, you just do as much as you can of it. But the drawing aspect with it is just, I guess if I were to because it's just if you make the wrong assumption, you're thrown right off board already.
Right. Yeah, you're wrong from the beginning. Yeah.
So it's, I think what it is, I'll try to give some light to that, where people usually make the right assumptions. What's the right assumed parameters you should make? Because they're usually, you think they vary. In the beginning, you think the Bernoulli equation, assumptions vary, but it's actually only sets and different things that you'll see, wording, keywords that you'll see. Okay.
Okay, so I have it written down, number 1. So I'll stop my share now and
All right, let's do it. Let me see if this works. Okay.
Do you want to, okay. Oh shit, okay.
What's up?
I was gonna say, do you want to see the answer to the solution first to make sure it's right?
For the first one?
Are you for sure? Yeah, or do you know for sure you got it right?
I'm pretty sure it's right. Like, because I had the same answer. Like, the answer, he gives you the answer, right? Like it tells you the answer. So, here. So, I guess for these ones, you know how, like, I think this is in the lecture note, right?
I think so.
Okay.
I honestly haven't looked at it. I've been doing homework for like 5 other classes. I haven't even looked at this class because.
Oh shoot, 5? Oh my god, yeah, that's kind of like high school. Yeah.
Yeah, no, and honestly, this is the class that I care the least about. So, yeah.
Okay. But
like
I said, no, it's good. It's good to be honest. But like, yeah, like I'm gonna say this class. The one thing that will make it easy is just doing more problems. Like that's what it is with this type of class. Like you can't just breeze. Oh yeah, I understand it. Like day before the final. Like, it's not conceptual. It's very quantitative. Okay.
Wait, so is this number 2, the homework?
It's not. This is the number 1, but then I made this number 2. Like number 1, I guess, is like the Young's modulus one. The 14.13.
Oh, we're doing number 2, not number 1. I thought we were doing number 1.
We're doing number 1, but I'm just I made this number 2 for, I guess, what I have here. It's still number 1, whatever.
Okay.
Okay, so yeah, it's kind of like so. If you're looking at this, it's kind of like with the video that you showed. Like, so you have this Venturi tube, right? And then here is like, it's kind of like the manometer. I'm just gonna call this manometer. I don't know what you guys call it, but this is the manometer, and then this is technically the Venturi tube, because this is not really a tube. Yeah. Anyways.
Right. Okay.
So what I laid out here are kind of like assumptions that maybe you can like read through and kind of build, and then ask me if there's something is confusing. But mainly, like, when you're looking at this, you want to make these assumptions, like know how you're gonna attack it. Like, for example, what's in your arsenal, or what do you have? You have the Bernoulli's equation, right? And then you have this Pascal's law, which is kind of like this guy.
Okay.
This is just the difference in pressure. But anyways, like, this Bernoulli's equation for a Venturi tube, this is not always the case for everything, but for the Venturi tube, you apply the Bernoulli in this portion, the Venturi tube, or where the gas is. And then the difference in pressure is where this manometer is, the liquid. Or, there's some gas, but there's some liquid in there where the liquid is. And that's how you're going to attack it, like, conceptually, before you do the equations. And then when the other assumption you should make, which is going to make your life easier, is that one thing that we talked about is like within here, when you're applying the Bernoulli's equation within the tube, since they have the same height everywhere here, the y1 or h, whatever, are going to be the same. So they're going to cancel out. Okay. But here you're going to have a difference in height, obviously. So this is because, and that's why you have a difference in pressure. I know your professor probably talked about that, but what I'm going to talk about a lot of, I don't know. I wanted to ask, is your professor going to like have, I guess, like, like conceptual questions, or is it like just problems?
I have no idea, to be honest. I haven't taken any tests or anything.
Okay.
So this is really going to be my first test.
Okay. Yeah. So, because most of our professors I know that teach fluid dynamics, they'll focus not so much on like the qualitative stuff, but mostly just like answering questions. But it's always good to have that. Like that's what I always put in like a lot of my I guess lectures, is not only understanding like, oh yeah, these are all the equations, attack it, or if you're given an equation, you're just gonna use it, right? But like the best thing is just to step back and like, oh, why are you applying them? So that's why it's always good to know, like, because they're gonna ask you like, if you increase the height, what happens to the pressure? What happens to the velocity? Okay.
Right. I wrote down some things about that already. Like, I know if the height increases, the pressure goes down. If the height decreases, the pressure goes up. Like, I wrote all those things down. But
that's awesome. Yeah.
With number 2, how would I do that? Like, how would I prove the following relations?
Okay. So with that,
or not number two. I'm sorry. Homework 2, number 1. I'm sorry.
Homework to number 1.
Number 1.
This problem, yeah. Okay, so what you would do, let's just jump to that, is the very first thing is the continuity equation, right? Like you have this continuity equation, right?
Right.
So you have to prove 2 things, and obviously it's going to involve velocity. So it's given that one of these has to be, like be isolated. You need to have this either V2 or V1 and everything else on the other side, right? But that's probably like, it's like a trial and error, obviously, with like deriving these equations. But in your thought process, probably like, oh, okay, I'm gonna use this. Somehow I'm given these A1s and A2s. So let's do this. So that's what happens. So like the second thing here is, okay, let's apply the Bernoulli equation. And so you get this whatever continuity equation, you plug it in here, right?
Yeah, that's what we were doing in the video.
Yeah.
Right.
So exactly the same thing. And then it's pretty much just algebra. Like you just move things around. And let me see. Yeah, you move things around. There's nothing really, there's no assumptions here. And then the one thing with this is, remember the difference in pressure? Like
it's delta P.
Yeah. Like you gotta be wary about like, how are you gonna manipulate things? Like put these 2 together, group them so that you can actually get this guy. Because you need this guy somewhere. Okay. So after you group that, you have your givens, manipulate your Bernoulli equation according to your givens. And then like it's pretty much just like, playing with like variables. And then in the end, what is that?
Wait, hold on. Let me read it. Hold on. 2. Where did that 2 come from?
Oh, okay. Which one? This one?
Can you just explain like how it's going step by step? Because I don't really get the algebra unless it's like explained to me.
Okay. I'll do that then. Okay. So do you understand this part?
Yes, I know that you substituted the rho GH into there for V2. Like you substituted V2 with this. That's all I know.
Okay. That part, yeah. So the V2 goes in here, and then this is what we have. And so this next thing though, like this third step, is what I did here is, so you know how like we said that the H1s and H2s are the same?
Yes.
So this H2, I plugged in here. They're obviously the same. And what happens after that? Like they're in like opposite sides of the equation.
They go away. Yeah, they disappear.
So I completely blew that off. And then what I'm left with is just this pressure and then velocities, right? Pressures and velocities.
Okay, right.
So after doing that, what I ended up doing was I had to move the P's. I had to move these P's.
Okay.
So that's what I ended up doing. Like I wanted to minus the P2 on both sides, and then group this guy.
This on the other side.
Yeah. So that's pretty much what I did.
So where did the 2 come from?
And the 2 is the 1/2. Because you're gonna have this 1/2. You move this to this side, right? And then once you multiply it, like all of the, you're multiplying it, you're gonna get 1 on this side, right? On the right hand side.
Oh, you just took away the 1/2?
I took away the 1/2
by multiplying it by 2.
Yeah, okay. I transferred it on the left hand side. That's like the easiest way, yeah.
Okay. All right. Okay, yeah. I see it now.
Okay. So this step, that's like 3 things. The H's are gone. The 2 I multiplied, and then I grouped the P's together.
Okay. All right. I see it now.
Yeah. Okay. That's the goal of this step. It was like I wanted to like simplify it, and then now like I'm looking at this like how the heck am I gonna like, because like what is the goal here? Like you need to get V1, right?
Yeah. See, so is that what the prove means? What do they mean prove? I don't know what they mean. Like, what am I supposed to do?
So I guess, yeah, I hate those types of problems, honestly. Like, I'd rather have like...
It's just so like vague.
It's super, yeah. I don't know. But what it is like, you got to do the manipulation. The answer is pretty much, it's given to you, but you have to show the manipulation. like the derivation.
Okay. Oh, like pretty much just show the steps.
Exactly. That's what it is in the end. Yeah.
Why don't they just say that?
Yeah, it's a math thing.
Oh,
you know
so
how like
dumb.
do you remember in geometry or whatever? I don't know if it's like algebra 2. They ask you to prove something. It's like a mathematical concert, whatever.
Yeah, true.
Okay, so does this part make sense?
Okay, we're there now. Okay, yeah.
Okay.
Okay, hold on.
So
Wait. Yeah, that part makes sense. Yes.
Okay, the main goal is like to get V1. You always have to have that in mind with these ones. And it's like, shoots,
Okay.
like I have V1 in 2 of these, right? Like how the heck am I gonna get that together, right? And it's squared too. So why the heck am I gonna do? So this is where I struggled. And then you're probably like, oh shoot, like how come you did this? Or how come you're doing this? And then for the most part, what I usually do is like, I don't like working with fractions. It's really up to you, you know? I mean, you could do this in many different ways. But like, so that's why I multiply it by, I wanted to get rid of this by A2 squared.
Oh, okay. I see.
And
so
then,
that way everything's just in the numerator. Then.
Exactly. Yeah, exactly.
Okay,
That's the goal of this guy, yeah. And then so
that makes sense.
This next step right here, let me see. This next step, what do you think I did here?
Well, since you multiplied on this side, you have to multiply it on the other side.
Yeah, right? I did that in the beginning, beforehand, but this part, what did I do?
And then you distributed the A2 squared.
Okay, but
no? Or no?
The I kind of factored. Yeah, it's you know how like V1, you want V1 to be alone, right? You want it to like show up one time. Because like it's showing up twice here, and I don't like that. Like I don't like. Well, shoot, like there's 2 of these. It's gonna be hard. Okay. So what I did is I kind of just, since both of them share that.
Oh, okay.
Yeah.
Oh, yeah. I see. Okay. I see it now.
Okay, that's good.
And you took out a row. You took out a row as well because a row is on both sides of the minus,
I wanted to say this. This is kind of like an aside, but like, you know how this row is just row, right? And then where is it? You know, in the end we have like 2 rows. Like this is the end goal. You have row liquid and row regular, whatever. This row here is the gas, right?
Okay.
This is the yellow part, the row here.
And that's the liquid, right?
Yeah. So this is where the part, like, I guess you have to step back again. Is like, which row are you using? I forgot to mention this. I think it's important. But you know how like you have these 2 equations, right? The Bernoulli and the Pascal law. When you have, wherever you apply it, that's the liquid fluid that you're using. So just to keep in mind with this Venturi is, I thought at first it was like going from here to here, but then if you look, that's why it's important where you're going from. Is 1, what is 1 really here? Is it A or B, whatever. Anyways, since you're applying this here, you're only using whatever that is, that row there. So both sides of the equation.
So what row is it? Let me ask you this. What row is it? Is it the liquid or the regular one?
It's the regular one for the Bernoulli equation. Okay. But then.
Okay, so the liquid comes later then.
The liquid here is where you're applying that, which is like this difference.
But yeah, so where do we apply that in the equation that we were just doing?
The rows or the liquid?
I thought you said that it was the regular.
Yeah, it is the row regular. That's why there's a difference there. And then what you want to do is, because this. Okay, Go ahead.
I'm asking for where we were. Go back to where we were on the steps.
Right here.
These rows here.
Yeah.
Which ones are for liquid and which ones are for gas?
Okay, so the whole thing we're using here, because like we're still in the Bernoulli one, is.
Okay, so we're not using the liquids one.
Not yet. Yeah.
Okay, that was my only question. Okay, that's fine.
Okay, good. Okay, so.
Okay, and then we factored out a V1 squared and a row.
Okay.
And then
what about this part?
Wait. So then, and then you just yeah, I get it now. All right. And then for here, see, I don't know what we did there.
Here?
Yeah, no. I don't know how you went from this last step to where
the
square roots are now.
Okay. Yeah. So after doing this part, you know how you have this difference in pressure?
Mm-hmm.
This is the only part that I changed. What I did here, I substituted the Pascal's law, or the difference in pressure.
Mm-hmm.
So this is where the liquid comes in, pretty much.
Okay, hold on. Let me write down. Hold on.
Okay, good.
I'm gonna write down Pascal's law.
Okay. What do you guys call it, by the way?
Pascal's law?
Yeah, like, does your professor call it Pascal's law, or just difference in pressure?
Difference in pressure. I'm sure she's mentioned Pascal's law, like here and there.
Yeah, usually like
I remember it as difference in pressure. That's what I remember it as.
yeah, the formal way, because Pascal did a lot of things, but yeah, like it's a difference in pressure. I think we'll stick with that one.
Yeah. Okay. So, all right. Hold on. Let me see. I'm really bad with like looking at numbers. Hold on.
Okay.
I have to like really, really stare at it for a while to like possibly understand what's going on.
Yeah. No, like this one, it wasn't that bad. It was just like knowing where to go, you know?
Okay, factored that out, I think. Okay, that's left on the bottom. Oh, I think I know what you did. Okay, wait. I think you divided out the wait. So you put everything over on the left side to isolate V1.
Yeah, right? I switched it though. I usually do this. So you know how like V1's on the right side?
Yeah, I see that. So we move everything over to the left side to isolate V1.
Yep.
And then you just square rooted it to get rid of the square on V1.
Yeah, at first what stumped me was like, why the heck is this A2 out here, you know?
Yeah, and that was my next question. Why is that A2 out?
It's because it's squared already. I thought at first you had to apply, like my first thought process of this was to apply the continuum equation. It looks like you would do that because you have A2 here, but that's not actually what you're doing here. Like you already applied it. I think you could do it either way, but you know, like do the Bernoulli first and then put this back, like the continuity. But the way I'm doing it is I put the continuity first in Bernoulli and then manipulate it. Right. If that makes sense, yeah. But that's technically what we're doing.
No, yeah, but that's what the chemistry guy did. He did the same thing. He did the continuity first, then substituted that in for V2.
Exactly, yeah.
Isn't that the way you're supposed to do it?
There's another way. Like you could technically, what you could do is you do the Bernoulli. The other way, I can imagine it's gonna be. I don't know if it's harder or easier. Seems like this is the easiest.
Yeah, it's probably gonna confuse me.
Yeah, so let's stick with this one.
Okay, so explain again. So we isolate V1 by dividing the row A1 squared minus A2 squared. We divide that, right?
Yep.
Put it on the other side. Okay, I got that.
Okay.
And then, where did the A2 come out?
So the A2,
it was on both top and bottom. It was on top and bottom.
Yeah, like because you're multiplying it, right? Like it's multiplied. Okay, let me see. Let me just. You know how like you have this guy, right? It's like right here, right?
Yeah.
And then like, this is before you square it. Like before you square this one, or you square root to it. I meant you have this guy, right? Mm-hmm. This is what you had. What you're doing.
Yeah.
You took this guy, divided it, and then this right here could be like it could be up here. It doesn't matter.
Oh, I see now. Because the square root cancels out the square. I see it now. Okay.
And then like do the heck the square. You're gonna do the square root. Everything here is good. None of these are squared. The only thing that's squared is this guy.
Right. I see. So it comes out. Okay. I just had to visually see it, but I get it.
Exactly. Yeah. That's why.
Yeah.
This program I'm using is Mathematica. I don't know if you're familiar.
I've never heard of it.
Actually, like it may be a cheat. So maybe I won't. Like if you like to use it's kind of like a calculator, but you could do a lot of these things. What I'm doing right here.
Mm-hmm. Yeah, it's pretty cool.
Yeah, but anyways, yeah, that's what I did. Like Like, that's all you have to do.
I see it now. Okay. Yeah, this is like reminding me of what I learned like in calculus a while back. So
Yeah.
okay,
So,
yeah, okay, I get it now.
so like, pretty much that's for V1, and then V2 is exactly the same. The only part that changes is this part.
Okay.
But does it make sense though for the other one?
Yeah, it makes sense. Yeah,
Okay,
I get it
cool.
now.
Yeah,
Cool. All right.
for these ones, I don't know if your parents gonna give you like another one, because like kind of like this where there's like no numbers at all. I know there's like some problem in the book, in the textbook, that like does a lot of these, but it's not like, I don't think it's like Bernoulli. But maybe just do some of those, and then the more you do it,
Yeah, I'll
even
practice that. Yeah.
even this one, like in terms of speed, I actually like, isn't the exam gonna be like, it's take home obviously, right?
It's gonna be online on
Okay.
Monday, and she's gonna have everyone have their webcams on.
Oh, big sister, that sucks.
Yeah.
No, like my
No, I
professor,
wanted to cry.
yeah, my professors usually don't like to do that because it's kind of, I mean, it's pressure for one, but it's kind of, I don't know. I mean, you might as well just use it as like an open book, I mean, you're out.
Yeah, right?
What's
Exactly.
the
Especially
point?
for people who aren't majoring in this, like, what's the point of making it so hard?
Yeah, but yeah, in fact, that for if this is not your background, yeah, it is kind of hard, yeah.
Yeah, it's not my background at all. But
Okay.
I mean, luckily I'm not like completely stupid, so I can do algebra if I like really, really practice it,
Yeah, that's
So
fine.
yeah, I just
I
have to practice.
I think math isn't really acquired, Like I think that's what people like. I think math is just, it's hard if you don't practice it.
Exactly. Yeah, it's like working out. It's like it's a muscle
Exactly,
that you
exactly.
have to
You're
you
right.
have to
Yeah.
practice. Yeah.
Okay, so I think
Okay,
this.
let's go to the next problem now.
Yeah, did you do this one already?
Number 2.
Yeah.
I mean, I copied it from Chegg, but I didn't know what I was doing.
Okay. 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 Okay.
But
I
I'm
guess.
down to do it. I'm down to do it because I want to learn it. So.
Okay. All right then. Did you want to like ask like what parts? Did you try to do it, or like did you try like just by yourself?
I mean, I read it on Chegg, and then I like tried understanding it, but I didn't really understand it. But actually, I don't know where I wrote it out. Honestly, I think I ripped it out of my notebook because after I
Okay.
turned it in, I was like, well, whatever. But I
Okay.
probably shouldn't have done that.
We'll just go over it. It's not that bad. Okay.
Okay, yeah, let's just go over it. Let me go back to the problem and read it so I know what I'm looking at.
Okay.
One second.
I technically just copied the problem here.
Oh, you did. Okay, cool.
Yeah, I think I made
A
this.
garden hose 2 meters off
Yeah,
the
that was a wrong
ground.
word. So there we go.
Hold on. Okay, so 2.
This one isn't bad, but like I think you probably have to like draw it out.
Yeah, for sure. Hold on, let me write it down. Garden hose.
Let me see if I can actually
Meters
do something
off
similar to that.
the ground. Oh, sorry. Could you lower it so I could finish writing the problem?
Here we go.
Thanks. Thank you.
Okay.
Does water flow out of the end of the hose. Okay.
All right.
All right. Okay.
Ready? Cool.
So I'm assuming we're gonna need the volume flow, which is just A1 times V1, right? That's the volume flow rate.
So like for this one, this is technically like it says 10 M, right? I think this is just a detractor.
Mm-hmm.
You technically like for this one because it's asking you how fast. So I guess yeah, like for these ones, yeah, like what I would say is like maybe are you using like the Bernoulli or would you be using like the continuity, you know?
Right. Yeah. Yeah. That's my main thing.
And then, I mean, the way I would do it is I would always default to for like 99% of the time, it's mostly just like the Bernoulli. Like that's my first thing.
Okay.
I would go to that, and then if it's not doing that, and then it's asking the one thing that would hint like, oh, okay, are you going to be using like the continuity? Is if it says like it gives you A1 and A, or like it won't give you A1 A2, but it'll give you the diameter of two things. This is only giving you one diameter.
Okay.
Yeah. So it gives you one diameter.
So you use So you use continuity when you have two diameters. Pretty much. Okay. This is what I was like hypothesizing, that you use continuity when you're only given like 3 out of the 4 things in the equation. So like 2 areas and a velocity, or 2 velocities and an area, right?
Yeah, it makes sense.
If pressure is included, then that's when you would use Bernoulli's, right?
Yeah, pressure, velocity. Yep, exactly. If you,
Okay.
oh yeah, like because like if pressure is here, but the thing is like you're thinking like, oh, there's no pressure in this one, right?
Yeah.
Like, it doesn't give you like pressure, but that's the thing. Like for the most part, I always jump to like Bernoulli, because like if you think about it, it gives you not just pressure but like elevation. There's a difference in elevation. This is off the ground. So I'm like,
okay.
Every time you have like a difference in elevation, it's default. You have to do Bernoulli.
Okay, let me write that down. That's a good tip.
Okay. Oh yeah, maybe we should go over this one. Like these are the assumptions we should make. Let me know if you're.
Yeah, hold on. I'm almost in writing it. Whenever there's a height difference of any sort, use Bernoulli's equation. Okay, cool. Ready.
All right. So when you're using this is like pretty much the bulk of the Bernoulli. There's actually a harder one. Like we can probably go over later on, but what you have to do is create these assumptions in your mind, or you can write it. But what it is you always have 2 points. They'll never tell you where they are. It's up to you. Like so you have to create like where am I coming from, and then where am I gonna go? Like that's like the first thing you need to do is where's point 1. So in my mind here, it's like, oh, point 1. It could be either
it's 2 meters off the ground.
Yeah, you could either like the best bet I do is either go with the tank, where the tank is, or where the garden hose is. You know, like they gave you 2 locations, right? Yeah, and then the one thing about it is you have to be very careful with like where you're choosing it, because like the signs, right? The signs of your elevations. Yeah. So,
I have a question.
Go ahead.
I have a question. So would you suggest that I have height number 1 as 2 meters and height number 2 as 10 meters? Or
you could do that. You could do that, yeah.
Or could I have it as height 1 as 0 meters and then height 2 at 8 meters?
Height 1 as 0.
Like just subtract the elevation from the ground, and just have where the 2 meter starts. start at 0?
For me, like it really depends. It really depends on you. What I usually do
could
is
either way work? Could
either way works. Either way, like that's the one thing about the Bernoulli. Like you've done like the mechanics class, right? The F equals ma.
Yes. Yes.
Yeah. This is fluids. This is like F equals ma with fluids, pretty much.
Yeah.
Because you could attack that many different ways, and then this, like for fluids, that's why it's like bad and good. Good.
Yeah.
But like it really depends on what you're assuming. But for me, like what do you usually assume? Like because like the thing is with me as what I'm doing here, I've assumed going down. Like that's the direction I'm gonna go. Like you can go up if you want, starting from 0, going up to like the tank, right? For my suggestion is like maybe follow the water. You know what I mean? Like because
follow the water.
Yeah, where's the water going? Coming from and going? It's coming from the tank, right?
Right.
Yeah. So that's what.
Okay.
Yeah, that's what I usually assume. Like I usually follow the direction of the water. But there's a but there. The thing is, if you do it that way, then you're going down, which means there's going to be a negative sign somewhere.
Oh, right.
Yeah.
True. So it does depend if you're. It does depend if you're starting from the bottom and going up, or if you're going from the top and going to the bottom.
Yeah, exactly. The sign. The only thing that changes is the sign. The answer is the same.
Okay. So should we look at what my teacher put?
Yeah, you
make sure.
Do you wanna like share that? I can probably just explain that one.
Yeah. I'm sure if you just have it in front of you, you'll be able to explain it like really fast. Okay, hold on. Let's go to. Okay, all right. I found it. Let me share my screen.
Okay. Yeah, let's look at this.
I'm going to solve this equation in terms of V1. You will need to write V2 in terms of V1 as well. What is the solution for that?
I see what you're saying. Okay. So that is what they did. Okay.
Okay. I get that. Okay. Yes. Very good. Now replace V2 in Bernoulli's equation. Got that? Okay,
this is the first one. This is the first one.
Oh yeah, it is number 1.
Which makes sense, yeah.
That's why I was able to understand it.
Because we did do that one.
Yeah, exactly. All right. No, it's still a problem. Okay. All right.
Yeah, this looks really good, yeah. I was gonna draw that, but good thing I don't have to anymore.
Yeah.
All right.
Okay. So what is that? Z1?
I think so, yeah. I saw professors are really bad at. Okay, anyways, yes.
Is that height?
Yeah.
That's height.
You could use either Z. I think she's using Z. I use H or Y.
Yeah, I like H better.
Okay, yeah, you can use H.
Okay.
Yeah. Oh, that's weird.
Okay,
she used Z there, but then now she's using H. Oh, I hate those.
Down there, yeah, that's annoying.
What the hell? Okay.
A hose of diameter of 3 centimeters, right? Okay. V2 that way. Okay. Isn't it 2 centimeters off the ground? Wait, didn't it say it was 2 meters off the ground?
Yeah, let me see that again.
Oh, she has it holding up right here. That's 2 meters, I guess. Oh yeah, that's 2 meters. Oh, okay, I get it now.
Exactly. Yeah.
She was so extra funny with like the person.
Yeah, I know,
okay,
right?
All right.
Confuses the heck out of you though.
Yeah, because it's like, oh, now there's like curves that we have to calculate or what? But no, it's pretty much just like this is the start point at 1 and then the end point, and that's it. Just like the difference between the two.
Anything in between doesn't really matter, yeah. Okay, go ahead.
Right. Okay. Similar to problem 1, we start with Bernoulli's equation. Okay, bueno. P1 and P2 are both pressure of air atmosphere. Okay, P1 equals P2, which equals.
Does that make sense? This is one of the assumptions. Yeah.
Okay, so they're both under the same pressure?
Yeah. So like this is always the assumption every single time. It always comes up. I guess. So do you get this one or?
Not really, to be honest.
So like with pressures, the one thing you could always assume is that's why it's good to create a pictogram. But like you know how like, or you can always imagine it because like physically, like you have this very large tank, right? And then you know how like it says open in the problem, right?
Yes.
That's the key word. That's always a key word because sometimes it says close. Sometimes it says
open.
close. So when it says open, that means pressure is always atmospheric, ATM.
Okay.
Every time. It doesn't matter what the heck this is. It could be like a bucket. It could be a tank. If it says open, it means it's ATM, PATM at that point. And then like number 2, like at the point 2, it's a hose, right? It's a garden hose. So like when is a hose ever like plugged, you know? Like I mean, it's always gonna spray something. So physically, that's the one thing. Like, so the tank is easy, it tells you it's open. The hose, it doesn't really tell you. You gotta be like, oh shoot, it's a hose. So that right there, it's open, it's discharging, it's also ATM.
Oh, okay. Assuming that the hose is open. Okay.
Yeah, and that's very important, right? Like now they're both ATM.
Okay.
So what does that mean though?
So I think it's different from Pascal's. I know that. I think it's like 1 ATM is like, hold on, wait, I have it written, I think, somewhere. One second. Let me refer. Okay. Oh wait, no, that's 1 Pascal. Okay. So 1 ATM is equivalent to 101.3 kilopascals.
Yeah, that's good. Yeah, but like it's good, but that's right. But like not the answer. It's what is not? Yeah. I'm asking more like step back and then like what does P1 equals P2 mean? Like what does that mean?
That they're the same value?
Yeah, but then like in terms of the Bernoulli like equation, what does that mean?
I don't know.
so you know how like every time something is equal to one thing, what does that mean in opposite sides of the equation? Opposite sides of the equation.
I don't know.
I think the answer is like right there.
Wait. Oh, they cancel.
Yeah, there. Yeah, I didn't actually read that, but good thing it's there.
So we can cancel those 2 terms.
That's the reason. That's the reason why like you want to assume those 2 things as ATM.
You don't always want to assume that because if you do, then they're gonna cancel.
Yeah, it's like because like it's too many variables. You won't be able to solve for anything.
Okay.
It's usually the case though. I guess for that one, like to go over it, like you know how like this one is both open, right?
Yes.
So that sometimes one isn't open, one is closed, and the other one is open. Every time it's closed, there's always going to be pressure. Something has to be. So if it's confined, they'll always give you a pressure. Yeah, and then you have to find the other one.
Now.
Yeah.
I see. Okay, that makes sense. Yeah, that would have just flown over my head, honestly, if you wouldn't have explained that. So thank you.
Okay.
So cancel that out of his equation. Okay, cancel that out of the equation. I got that.
Okay.
So pretty much P1 and P2 are gone. So
we're
left with 1/2 rho V1 squared plus rho GH1, 1/2 rho V2 squared plus rho GH2. Okay.
Okay.
The tank has a large diameter, So we can consider the velocity of water at the surface of the tank.
All right, stop.
Wait, what? I don't get that.
Yeah, okay. I knew, yeah. So this is the second. This is the second, yeah. Not like everyone always gets, like, these are the assumptions. We have to go over it. Because the assumptions will make your life easier, or maybe it'll confuse the heck out of you.
And I think, that's what really messes me up. Okay.
But like I said, like, we just have to, like, go over it. It's like one of those things, like, once you know it, you'll never forget. But anyways, like, for this one, like, every time, that's why they tell you it's a very large one, right? It's like a large tank, right? They tell you that. Why does it matter? You probably wonder, why does it matter?
Because more water will flow out of it.
So like, do you remember, like, the continuity equation?
Yes. A1V1 equals A2V2.
Okay, and then what is the essence of that? Like, it's size versus what?
It's area times velocity.
Okay, so the larger the velocity, the larger the area. What does that mean?
The larger the area, I think that it's slower velocity.
Yep, you got it.
Yeah. All right. Cool. Yeah.
So what does that mean in this? What does that mean in this case? Like, applying that, like, you pretty much you got it, but, like, you have to apply it here then.
Yeah. So okay, the larger the area, the slower the velocity.
Yeah.
So
why is it zero though?
Consider the velocity to be zero. Because it's at its.
When it says very large, what does that mean though?
It's a large area.
Do you remember? Here, I'll just shoot it out. Like, do you remember infinity? do you remember infinity? Like, the number, it's not really a number.
Right. Yeah. Infinity. Yeah.
So when it says very, the key very, and then large is a second, it means it's going to infinity. Like, the A of this tank is going to infinity. This is what this means. So since it's going to infinity, and then you're telling me you know the relationship, right, of size versus velocity?
Yes.
So if, like, something is going super large, then, like, the size of it, of the diameter, whatever area, then the velocity has to go where?
Down.
Yeah, to zero.
To zero.
Yeah.
Okay.
So yeah,
that's a pretty heavy assumption.
It is, yeah, I know.
But I think it's okay. I think we can assume that the area is infinity just because the diameter isn't given, and it's just saying that it's large, right?
Yeah, but then, like, just to I guess abridge that, make that easier to remember. You're not gonna be like, oh shoot, the reason why V1 is this is, you're not gonna write the whole thing we just talked about.
Right.
Like, what I would, like, think easier to think is, every time it says very large, this is what makes life easier. When it's, have these keywords, very large means very large, like, whatever this is, means velocity is zero. That's what I would just do.
Okay.
Like, you don't have to know why, but just know that.
I'm gonna just put very large equals zero velocity.
Yeah, exactly. Yeah. Same with the other one too, the ATM. Like, make it make sense for you. Like, why is open means ATM? Make it make sense for you. Something like that.
Right. Okay. All right. Got that.
Cool.
Okay. So now Bernoulli's equation becomes even simpler because now the velocity is zero, right?
Yep.
For
and now you have
V1.
3 terms. Yeah.
So V1 got canceled out. The 1/2 rho V1 squared got canceled because V1 was zero, right?
Exactly.
Okay, cool. In this problem, rho is the same in all the terms. Okay, so we factor out a rho.
Yeah, but
did she factor it out or she just canceled it out? Oh, she canceled it out.
Yeah, because it's pretty much the same.
Yeah.
Like, both sides of the equation.
Right. Yeah, I get that. Okay, yeah. Cancel out the P, the P, the P. Okay, cool. And then, with the rho I meant. Okay. And then, so we're left with this. Cool. I got that.
Okay.
And then, okay, so now we have H1 is 10, H2 is 2. Oh, and then you just plug in and solve, huh?
Yeah, it's very simple now. Yeah, everything's given except for a V2.
Nice. Bueno.
Yeah, I think that's what I got
too. Can we go over?
Yeah,
Can
that's
we
what I
go
got.
over the algebra of that part?
Which one?
Of this from.
Oh, okay. Yeah, she didn't write that. She didn't write that. What I would do
No, yeah,
is
she just gave the answer of the square root.
Yeah, I don't know. They usually do this, which sucks and it's sometimes good. But if once you have this 1/2 V2 squared,
multiply by 2, right?
Yeah, like so if you write that, you put it on like the left hand side, and then I think where is it? Yeah, and then after that, so that's where you have this 2 right here. That's like where you have this 2. Let me see. That's why you have this 2.
Wait, hold on. Wait. Oh, I have to prove something. Would like to control this computer using accessibility features.
Let me see if I can actually because I don't have my mouse. Try to approve that one.
Let me see. To approve. How do I approve it? Let me see. Allow the apps. Did it work?
Do you see my mouse?
No.
See my mouse?
Try it again.
Okay. What about now? I think you should be able to.
No.
Okay, whatever. It doesn't matter. I'll just say it. So like this 2, this 1/2, right? Like you move it here on the left hand side, and obviously you're left with V2 squared on the right hand side, right? V2 squared, and then so that's why you have this 2 here with times 9.8, which is like the G.
Oh, I see it. Yeah, in the square root.
Yeah, and then times 8. 8 is 10 minus 2, and then the square root is after you V2 squared, you just square root everything.
Wait, but why is 9.8 only written once if we have 2 G's? Do we cancel them?
2 G's. Oh, I see what you're saying. This pretty much factored it. Like G it's pretty much the same. So you just factor it out.
And so where did it go? Oh, it came out. Oh, I see it now.
Yeah, you could do it either way. If you want to do it like GH1 minus GH2, and then times those like 2 GH1 minus 2 GH2, and then square root that, it's the same exact thing.
Wait, hold on. Okay, so GH1, because I'm literally not gonna understand it if I don't write it down.
Exactly, yeah. That's the thing with this class. It's not very concept, it's all quantitative.
Yeah, for sure. Okay, so we're gonna multiply by 2 on that side, cancel out the 2, so we got a 2 here. So now we're left with 2G H1 minus GH2 equals V2 squared. Okay. So, wait.
Makes sense.
No, wait. Because I see how the H's get subtracted, right? Because it's 10 minus 2, which is 8. Yep. But I still see 2 G's.
Yeah, and then you times those by G. You times the 10 by G. You could do it that way. Times the 10 by G, and then the 2 by G, and then minus them.
Okay. All right. Work. So then now we have 2. Hold on. So 9.8.
Okay.
Times. What's 9.8 times 10? Hold on. Let me get my calculator.
Okay. I think you just moved the thing. Never mind.
Move the what?
I think you just moved the decimal.
Oh, what? How?
It's 10. Never mind. Just use your calculator.
Oh, yeah. No, I'm not visual like that. I can't imagine it in my head like that.
Okay.
10 times 9.8. 98. Okay.
Yeah.
So 98 minus, and then 9.8 times 2.
Yeah.
Which is 19.
It's exactly the same.
6. and then 98 minus 19.6. So now I'm left with 2 times 78.4 equals V2 squared.
Yeah.
And then 2 times 78.4 is 156.8. So square root that, and then square root, cancel out. Okay, but see, I don't get in her work how, oh no, okay, I get it. She factored it out because the G would still distribute to the 10 and the 2.
Exactly, yeah.
Oh, okay. I see it now.
That's good.
But wait, sorry. But here in the square root, why isn't the 9.8 doubled or distributed?
The 9.8?
Yeah.
She factored it out. I think it's pretty much like it's just multiplied. She did the H.
Wait, so you can subtract the 10 minus 2 first?
Yeah, you can do that first, yeah.
Oh, I thought you had to distribute first.
Either way works, as long as your math is like correct. You know, like you could distribute first or minus and distribute. It's pretty much the same ending.
Oh, it is? Oh, I didn't know
that. Yeah. Right? I mean, like you could prove it.
I kind of want to test it. Hold on, I've never
try it. Yeah, it's like an
thought about it that way.
Thought experiment.
All right. Okay. All right. So 9.8 times 10 is 98. Wait, no, that's what I just did. Okay, 10 minus 2 is 8 times 9.8. Oh shit! It is the same.
Oh, see, whatever makes sense for you. It's always like that thought process.
Yeah. Okay.
Because like you know, I mean, the journey is the destination is the same. The journey is different. So.
Yeah. That was really deep.
It's always a math thing. You can do your own math, but like the concepts will always be the same.
Okay. All right, I got it. Wow.
Perfect. Wait, so these two are there other ones for this homework? Seems like
nope, that's all for that homework. But we have the practice problems. But what time is it?
Yeah, it's 2:30 almost. It's actually over that.
So wait, we started at 1:30. It's 2:30 for you. Oh wait, so if we do an hour and a half, we still have like 15 minutes.
Yeah, let's do that. Yeah.
Let's do that. Yeah, we'll just do an hour and a half. Okay.
Actually, I already filed the you know how like you always have to file a note after.
Yeah.
Like, for the session, so I already did that one.
Okay, so we're filing it for an hour and a half.
Yeah, but like you know for other ones like you can just book as many as you want. Like for me like that's why I have the Zoom pretty much like if you look.
So you can just like dock in the hours later.
Yeah, for Zoom for me like I made like 2 hours. If you need more time, it's up to you. I'm.
Oh, okay.
Yeah.
Okay. Well, we'll see what we're gonna do right now.
Okay.
Let me see. All right. Cool. Yay, we got it. Woo-hoo.
Man, that's a super short homework for you guys. It's 2 problems.
Really? I think that was
usually
hard for me.
For fluid dynamics, usually like 10. You know, I mean like tons and.
Oh my God, Jesus Christ!
No. Yeah, I know. Because the thing is that's how you concretize. You know, your the concept.
Yeah, that's true.
But yeah, you're right. I think you've mastered it already. So.
You think? Oh, thank you. That's very nice of you. That's very positive encouragement.
Let's look at the practice problems. I see.
I don't know where she. Oh, there.
Oh shoot! Okay, these seem like. let me see. Look at this.
Too soon.
Density will not change. Okay, so these are like she's doing concepts. Okay, so she is doing concepts. Ooh, See, like I hate the fact. I mean, a lot of fluid dynamics is really because a lot of these is just are there like what's the other ones? Like there's 1A, 1B. Okay, 3. It's still a concept, really. And this one, oh man,
Concept again.
yeah, I hate professors that do a lot of concepts because this class is not meant to be a concept class. Like it's really just like knowing the equation and when to apply it. Because like if you make it conceptual, it makes it super hard. Okay. Okay, so that one, yeah, it's still a concept. Like, or maybe is it all concepts? That's crazy. So. It's all. It is all concepts. What the?
Damn.
You know, I did some of the problems. It kind of looks like it's very similar. Some of these.
Okay. Let me see.
Okay, there's more. Oh, so this is the one you're talking about. Shade in squares. What the? Okay, this one looks similar to the problem I just did. Elasticity. Okay, another concept.
Elasticity as well.
Which one are you better with, the fluids or elasticity?
Fluids.
Okay, it's not that bad. They're pretty much the same thing. Like it's just different mediums. Okay, we'll go over it. Like which one though? I mean, there's a lot of things to go over.
Yeah. Oh God. I guess the first one.
Okay, so the first one isn't that bad. So you know how like this is actually one of the problems. Try look at the one that I sent you, or if you let me look at this and see where it's like very similar. Okay. Density will not change, and both mass and volume increase by 8 times. It's actually the first one, 1A here is 1CQ. If you look at the problems that I sent, it's like 1CQ.
Oh God, I don't get that. Wait, okay. Suppose each of the, sorry, I'm just reading the first one. I'm trying to like conceptualize. Suppose each of the objects 3 dimensions. Suppose each of the objects 3 dimensions is increased by a factor of 2 without changing the material of which the object is made. Will the density change? No. Okay, yeah, that makes sense that it wouldn't change because you're not changing the material.
Yeah. You know how like this is her solutions? Like, are these her solutions?
Yes.
Okay. I really don't like her solutions, to be honest. Like, can I share my screen? Like, I want to show you how it should be done.
Yeah. For sure, yeah.
Because like the way, I mean, everyone has their own way of doing it, but let me know when you see it. Okay. So this you see it?
Yes.
Okay. So that I think that exact problem is problem 1CQ. Like it's this problem, right? Like to try to see.
Yeah, it's pretty much the same.
Exactly. Okay.
Yeah.
So so the way I would do it, because like how long is your exam? Is it timed or?
Ooh, yeah, it is timed.
Okay.
It's the length of the class, which is an hour and a half.
That's not long, because if you do it the way I do it, you know what I would suggest? It's probably challenging, but like I mean I already gave it to you, so these are all the problems pretty much. If we go over like what she gave you guys, like it's probably like more than half of it is like what we already solved. It's pretty much in the textbook is what I'm saying. Like so what would make it easy if she keeps the same like pattern is if you do the problems ahead of time, then it's you
have it with me.
Yeah, because like right, I mean it doesn't matter if she's watching you guys. Like
right, because I can just have it in front of me and she wouldn't see me.
Yeah, and this is.
Or she would see me, but she wouldn't see the paper.
Yeah, it's pretty much like how prepared are you, you know, like for it. Yeah. I don't like those tests, but it doesn't matter. But that's what I would suggest, because then, though more than half of the problems, anyways, yeah, it's like in the textbook.
Yeah, true.
But anyways, like for this one, you know how like it's asking you like what is the this factor. You just do like the best way to do it instead of like just giving you like, oh, here you go, and then one sentence, right? She give you one sentence or two.
But you know what? I think I'm not saying like for all of them it's gonna be like that easy, but for that one,
Yeah.
I think it was easy for me to conceptualize because I already work with density in my major. Like so like I already know like density is like it's like a quantity for like a certain material. Like it doesn't matter how large, you know what I mean? So yeah, like the density of oceanic crust and continental crust, it always has the same density because of its composition. Yeah, it's like constant. It's a constant. Yeah, so
perfect. Yeah, you could actually just do that. Yeah, like if something like that is like as like just one word or one sentence done, then yeah, you could definitely just do that.
Yeah. So let's go to the next one. Let's see if it actually does need more thinking than what she wrote. Okay.
Let me see.
Suppose each of the objects' 3 dimensions is increased by a factor of 2 without changing the object's mass.
Okay.
Will the density change? If so, by what factor? Okay, that seems a little harder.
What did she put?
Density will decrease by a factor of 8.
Okay, did she provide an explanation?
So P1 over P. Okay. Okay, she just like factor 2. Why 2, 3?
Why 2, 3?
Yeah. Oh, because it's 3 dimensions.
3 dimensions, yeah.
Factor 2, 3 dimensions. Okay. And then 1/8. How did she go from this to 1/8?
It's you know how like the mass doesn't change, right?
Okay, right.
So if the mass doesn't change, then you don't cancel the V.
But you cancel the M's.
And then you all, since you don't have that like you don't have that the 2/3 up top, it doesn't cancel the bottom as well. No, actually, no. Let me tell you, the V naught does get canceled, but the 2/3 doesn't get canceled. So that's why you still have it at the bottom.
Oh.
Because the 2/3 is because of the what is that one? That's the change of mass.
2 to the power of 3 is 8.
Yeah. It's 8. Yeah.
Okay. 2 to the power of 3 is 8. Then how did it go from 8 to 1/8?
Because it's only in the bottom.
But I thought it was on the top.
So like, you know, the first one, the first one, it's in both the top and bottom.
Top. Wait, the first one. What first one?
A for A.
What?
Yeah.
Oh, this one. Oh, okay.
Yeah.
I don't get it.
Okay, hold on. Let me see. So you know how like the first one, the A. This one, your mass is still changing, right? Like
yes.
you modified your mass, right? So like so this first one is our original mass. This is for the first one, like 1A. And then like what I have here is like the modified mass. Like you pretty much updated it, and the update is this thing right here.
Oh.
So this is where you're getting this 2/3 from. 2/3, 2 to the power of 3.
Oh. So the bottom MV is 8 over V.
Yeah. So for the 1A, you both have. This is where the difference is. For 1A, you both have this 2 to the 3rd in both top and bottom. But for the B, you only have it at the bottom. Because the mass isn't changing, right? The mass isn't changing, so nothing happens. There's no 2 to the third.
But why is 2 to the third on the top of the fraction on B?
A? On B?
Yeah.
It's only on the bottom.
But it's on the top. The
Which
2/3. 2 to the power of 3 times volume over.
For 1A or 1B?
Over volume. 1B.
1A. In what? In mine's or in hers?
Okay. In B, we're on 1B. Okay. There's P1 over P equals M1 over V1 over M over V equals M over 2 to the power of 3 V over M over V. So my question is B.
For 1B.
1B on fluids and elasticity.
Yeah, like there's no 2 to the thirds at the top. It's only at the bottom.
It's right there.
Yeah,
M
right here.
over. Look, I'm gonna share my screen.
I don't know what he's looking at. Let me see. Share it.
Okay, I'm sharing it. That's funny. Wait, where is it? Okay, hold on. Where'd it go? I thought you were looking at what I was looking at. Okay, look right here.
Okay.
Okay.
Oh, that's what you're talking about. That's what you're talking about now.
Yeah, like what?
I have no idea what you were saying. I was like, what the heck are you talking about? Let me see. See, I don't like her solutions, honestly. Why is she like the way? Because she doesn't even explain. I'm not attacking your professor, but
Right.
the way she's like.
She just assumes everybody's smart, like her.
Yeah, because she has a doctorate. That's why. That's the thing.
Yeah.
Which doesn't really mean anything.
Right.
It just means you have time.
Yeah, like you have too much time on your hands.
Okay, whatever. So this 2 to the thirds. It is on top, but then it's being divided. So it should be at the bottom. Do you see it? It should be at the bottom.
Yeah.
Because like it's like M divided by 2 to the thirds, but then you have this other division thing. So this 2 to the third should be at the bottom, yeah.
Oh, that's what's throwing it. So we just ignore the bottom M over V?
So there's a bottom M over V, and then you know how like M and V are both up top and bottom? In like the same exact location, right?
Mm-hmm.
They all cancel out. Because it's exact. This is like a nested fraction, which I really hate. Because then you have to simplify it. Like she obviously like skips that step because I don't know why.
I think it's like where you multiply like the two tops and then you multiply the inner.
Exactly, reciprocal, all of that good stuff.
That's where that came from. Okay.
Yeah.
Okay. I'm remembering now.
Yeah.
Okay.
Yeah, but that's pretty much, yeah. I mean, it's short stepping, but like, yeah, 1 to the 8th.
Yeah, that's the thing. I don't do well with short steps.
That's why.
If I have it all there, then I'll understand it. But if you skip like one little step,
yeah,
I'm like thrown off.
That's same. Like that's why I don't like these solutions, because it's like there's so much assumption, and she's like, let me just give you the ending, you know, the end goal.
Yeah, exactly.
I'll let you figure it out. Yeah. But anyways, yeah, that's like A and B. And what about the other ones?
Okay, A.
Let me see if this one looks like a similar problem too. Let me see. What is it saying? What will the density of the air? It's kind of similar though, if you look at it.
Mm-hmm.
I can't find it. Okay.
Do you want me to, do you want to share your screen?
For which one?
For,
I think some of those, like, that problem is not really like, she probably made that one up. It's not like, it's very similar to 1A and B.
mm-hmm.
But like,
But she says, I understand it, but where she says M1 equals M, what does that mean? It's another assumption.
M1 equals M.
M.
For which problem is this?
For 2A.
Okay, so for that one, yeah. So she's probably saying that it's the same mass, right? I think that's what she's saying.
She's saying, she says, air enclosed in the cylinder has density rho equals 1.4.
Yeah, so the
kilograms
rho is given.
per meter.
Yeah. Okay.
Yeah, so the rho's given, but she's saying that the length of the cylinder is doubled.
Okay. Actually, can I see that one? Like, it's honestly not in this. Like, the problem set.
Oh, okay.
Yeah, let me see what that says.
Sure. Okay.
You can probably fill the steps.
Okay. Why does it do that?
Okay. So let
So
me read
2A.
So it's doubled. So what will be the density of the air if the length of the cylinder is doubled? Length of the cylinder is doubled. So if the length is doubled, you're just timesing the volume by 2. Yeah, that's what that means. While the radius is unchanged. While the radius is unchanged. Yeah, that makes sense. The mass, M prime, yeah, so the rho, what does it say, the length of the cylinder? Oh, she's saying that M prime is the same then, to M. And then since the length changes, then the volume is times by 2, which makes sense, yeah? Does that make sense that the volume is times by 2? And then, but the M is the same for both?
Like the mass is the same?
Yeah.
Yeah. Yeah, rho, the density of the air, length of the cylinder is doubled. What will be the density of the air if the length of the cylinder is doubled while the radius is unchanged?
Because it's both air. Because it's both air. It's just the cylinder that's changing. The mass is the same because mass is associated with the material, really. So it's air. So the mass is the same, but then the V is not the same. Mm-hmm. And then, so the mass is gonna cancel out, and the V, but then you have this 1/2 left.
But wouldn't the mass increase if the cylinder is getting bigger?
It's your volume. It's only your volume. Your mass is gonna be like, gonna be the same because of the air. It's still the same air.
Oh, okay. So we're not taking into consideration the weight of the cylinder, like of the cylinder itself?
Yeah, the one thing that's gonna change only is like because the weight of it doesn't change. It's just the volume, and then the density, the rho, is the one that actually changes, but the mass stays the same.
Mm. Hmm.
I don't know if that makes, but it says the cylinder is enclosed.
Mm-hmm.
The mass is the same. So that's another keyword. Air enclosed means the mass doesn't change. It's like one of those things that is
Oh, okay. Air enclosed in the cylinder.
yeah.
Oh,
But
okay.
obviously, if the mass is the same, conservation of like mass, something has to change, right? Something has to change.
Oh,
Mass
the
is the
fact
same.
that it's saying air, yeah, the fact that it's saying air enclosed means that it's just talking about the air, like the mass of the air only.
Exactly. That's my
Oh,
explanation.
okay.
But she's saying the cylinder is enclosed. That's what she's saying. That's why the mass
Yeah.
is the same. I'm saying
Okay.
the material is the same, so the mass doesn't change, only the volume
Yeah.
and the
Okay,
density.
I get it. Okay. All right. Well, I think we'll stop there. I'm gonna practice what we learned today,
Yeah.
and then hopefully we can have another lesson tomorrow. What's your availability tomorrow?
Oh, sure, yeah. Let me see. Mostly in the afternoon, probably after 2, my time.
After 2?
Yeah. What about you?
Okay.
Anytime after 2. Like,
Um
just what's a good time?
um I'm not entirely sure what my schedule is tomorrow, but I want to say maybe like around 4:30.
Sure, yeah. That's actually a good time. Like,
Yeah,
every
4:30.
for Sundays, usually it doesn't matter, but like I usually prefer like later, which is like that's a good time. So for my time or your time?
Um, my time.
Okay.
So
What
4:30
what
my
about
time,
what about
3:30
this?
your time.
Yeah, just book it and then like I'll we'll do the same thing, you know?
Okay. Yeah, that works.
Okay, cool. Yeah. Oh yeah. I gave you like I don't know if you looked at like the ending of the PDF. If you have time, I think a lot of the
Huh.
the textbook it has like other problems, right?
Yeah, I don't have the textbook though.
Oh, you don't have the
So,
textbook?
no, I didn't pay for it.
I see. Doesn't matter then. I guess you could just go and check and then like do the problem.
Yeah, I figured with Chegg and like having a tutor for the homework problems, I'd be fine.
Yeah, you'll be good. But like, yeah, the what I'm referring to are like the P problems. I don't know how to designate those, but like I think it's after 37, 38 to like 75, I think. 38 to 75.
Okay.
If you're bored as hell, just do those.
Okay.
Okay, cool. All
All
right
right.
then.
Okay, thank you. I'll see you tomorrow and I'll book it on the Frog
Shoot. All right,
for
bye.
tomorrow at 4:30 my time, so 3:30 your time.
Yeah, and then just like I'll put the Zoom for 30 minutes more than what you book it.
Okay. That sounds
Cool.
good.
All right then.
Okay, thank you so much, Paul. Have a good rest of your evening.
All right, you too, Elsa. Night.